Welcome to this talk about the dark side of microservices. If you still don't know me, despite the fact that I already made a talk and some people are still attending it, I am Nicolas Fränkel. I'm a developer, software, nobody cares about anyway. So we'll check my resume on LinkedIn. So this talk is about microservices. And microservices is about that on conferences, right? Who is doing microservices here? Hey guys, everybody tells you should do them. If you do microservices, your information system will become super nice. If you do microservices, you won't ever have a management problem because you will have nice teams. If you do microservices, love will come your way. No, they won't go as far, but practically what they promise you is, the wonderland. Everything is nice, everything is great, just magically. So you use the technology and everything works out fine. Guess what? Some people are bitching against it. Because, this guy is Simon Brown, is talking also a lot about architecture and codes and how you can code your architecture. And he says that, you can't go the microservices way if you don't know how to build a monolith first. It's not possible. It's software engineering. Or if I want to be funny, which I'm not, you remember this guy, Clippy, from the old Microsoft words? Like, let me help you. Who remembers? Good. Even young people. Be very afraid. So let me help you to structure your polystructure monolith into a polystructure set of microservices. Well, it's not very wrong. Because in real life, it looks more like that. Sure, there is light above, far away. But probably you are standing at the bottom, where it's hot and fiery and not nice. So there are stairs. You can climb the stairs, but it's hard. So I propose to you to talk more about that in detail. So first, what are microservices? What is a common definition? Then, what benefit should you expect? Probably not love, but something must be there at the end, right? More importantly, what are the requirements? Because there are requirements for microservices. And the last part, which I think is the most interesting, is even if you don't do microservices, probably there is something in it for you now. So what does it bring to you? So since I'm developer, so I'm super lazy, I took something from Martin Fowler, Blicky. And basically, it says, a monolithic application puts everything into a single process. So when you want to scale, you scale everything. And the assumption behind that is that all the functionality of your application have the same load. Whatever your application is, it has the same load in every component. And it doesn't make so much sense, right? For example, let's take the example of an e-commerce shop. Does an e-commerce shop have the same load into all functionality? Well, you can browse the catalog. You can put articles in your web cart. Probably there are a lot more people browsing the catalog than putting article into their cart. And there are a lot more people putting stuff into their cart than logging in. And there are more people logging in than going actually to the checkout. And even in the checkout phase, you have a net loss of people. So probably it's like an inverted pyramid. So essentially, it doesn't make sense to replicate all the features on different nodes because they don't deserve the same attention. In the end, you will end up scaling for the catalog. And the payment and the checkout won't be used as much. So no real not really interesting from engineering point of view. However, a microservices architecture puts each functionality, each feature into a single deployment unit. So when you want to scale, you put as much components as you need of the desired feature. So this is the basic stuff. And it follows an essential principle of software engineering. It's a single responsibility. So you've got one component, one responsibility, one unit of deployment. So it's based on component. It wraps a single business capability. They are decoupled, and they communicate via a simple channel. So do we all agree on this definition? Nobody says no? That's good, because the rest is based on this. So what can you expect? If you do that, what are the benefits? Because you don't go into this kind of architecture without expecting something in return. That would be pretty stupid. Like I said, the main differentiator is you can scale independently. So you can optimize your resources. You can deploy more units of the stuff that is really needed. Like you would scale more the catalog component and scale much less the payment. So if you pay for infrastructure, basically you optimize your costs. That sounds nice, and it makes sense. However, that's not the only thing. From a release point of view, since now you have different components, you have different life cycles. And different life cycles means you can deploy things independently as long as you respect the interface contracts. Here, how many people have released trains? Not so many. So how do you deploy, guy? I wonder. If you have monoliths, it's super hard. Probably you have released trains, or I don't know, and let's discuss about it afterwards. Microservices let you avoid this kind of let's deploy everything at once, and it's a super huge process, and let's have like 1 month of QA before, oh, we missed the date, we cannot do otherwise. Likewise, if you have simple decoupled components, you don't need to think about your whole architecture upfront. You can defer decision as long as you agree on the contract of communicating between your components. So you can migrate one component without migrating the other. You can change continuously without major rewrite, without major impact. And so it decreases the costs of migrating, of changing. And that is super good. One good benefit of microservice is that one of the tenets of microservice is that you don't share data between microservices. Each microservice has its own data store, has its own database. So basically, you can use SQL when you need to use SQL for transactional stuff, and NoSQL when you want more like evolutionary changing schemas. You can choose the best data store for the job at hand. You don't need to have SQL and try to force strange stuff into SQL or try to force transaction into a NoSQL store. What I less agree on, but it's still seen as an advantage, so I will tell it, is you can choose the language you want for the component. So you would have PHP for one component, you would have Java for one component, Kotlin, Scala, what have you, .NET. As long, again, as you have an interface that allows, and generally it's the case, for those inter-component communication. In my case, that's not really an advantage because that would mean that the recruitment process is really hard. But again, that can be debatable. So who wants now to do microservices? Because, yeah, that's great. Everybody wants to do microservices because it's so hype. Now comes the hard part. Requirements. Nothing is free in this world, even in Ukraine. First is, since everything can be deployed separately and will be deployed separately and will be deployed continuously, you cannot rely on a manual process anymore. It's not possible anymore because you cannot have microservices and say, okay, we will do everything manually, it will take like 2 days, and no. You want to do that seamlessly. And in order to do that seamlessly, you want to do that to automate everything. So, first step before you go into microservices, you must already have in place an automation process somewhere. Automated deployment. Without automated deployment, no microservices. Documentation. Hey, developers like that. Yeah. Now, you want microservices, but you don't want to write documentation. You want to write code, right? Because that's cool. Documentation is super boring. Who likes documenting his stuff? Great. You are not a developer, sorry. Yeah. If you want to give components to users, you have to document how your component works. Now, the API is not enough now. You don't have Java docs. You cannot read the signature and just magically know what it does. You can read the code. You are now isolated. You are not decoupled from one another. So you have to write stuff that is not code. Sorry about that. So surprisingly, also, you have to do monitoring. And not your grandfather's monitoring, real monitoring. You have to understand that by using microservices, the flow of data won't go from one API call to another API call, but will go from one component to another component to another component. So you have to be able to do some monitoring across components, to follow the flow of data across your whole component chain, back and forth. And basically, that requires some tooling, some skill set to put that into place. So if you don't have those, if you are not prepared to go into there, don't do microservices because you know that it will fail. Still, you will say, okay, I can even do documentation. I'm happy to do documentation. That's the love of my life. Okay, I can do everything. Let's go microservices. And now you've got core issues. And those are really deal breakers. This is UML diagram. Real advanced stuff. A calls B. And this is what I do when I call an API. And now this is microservices. A calls B. So what the change? We are not calling an API anymore. We are calling the network. We are making a call through the network. It changes everything. Who know about this stuff? The fallacies of distributed computing. Who knows? Yeah. And this is the technical deal breaker about microservices. First, the network is reliable. Sure. Even in your own company, the network is not reliable. Latency is not null. The bandwidth is not infinite. For who also went into developing because they don't like security, I'm sorry, but you will have to put security into place. Network topology will change. The nodes will change. IP will change. There are multiple administrators doing multiple stuff, different stuff. Perhaps they don't communicate so good. Yeah, and so on and so forth. Network changes everything. People that tell you about the benefits and how microservices can just help you, they don't tell you that. You will realize that, hopefully, sooner than later. Because it can break everything. Let's just talk about latency. Latency. So either you still perform synchronously, and then it makes the performance, the response time higher. Or now you say, no, I will do asynchronous call. And then you will need to handle that into your code. You add more complexity to your code. Are you prepared to handle it? Perhaps. Let's see. You have failures. Yeah, sure, you have failure. Hey, we already have exceptions, so shit happens. Sure, it can happen. But the way of handling it is completely different. Because you will probably have an error that comes in the form of message. Or perhaps not. Or perhaps never. Or perhaps after some time. You have no clue. You are just running in the dark, blindfolded, and hoping that something will come back. So you still have to think about that. Problems. Problems might arise. Also, what you want to do is probably you pass data from one microservices to the other, getting whatever, business objects. So you will need to serialize this data and unserialize it. Who did SOAP before? SOAP architecture stuff. You remember about XML serialization, right? At some point, I stumbled upon an IBM hardware that was dedicated solely to XML serialization and deserialization. It was so bad that they really created a hardware just for that. But now we have JSON. It's so much better. Yeah, but it won't help you with serialization and deserialization. I'm sorry. So, again, performance drop. Is it worth it? At some point, you will probably need to strike a balance between the scalability and your performance. As we said, the primary benefit is about scaling. So, if you have 100 of concurrent users, probably you have no issues about scaling. You have no problem. Your life is good. 1,000, still no problem. Afterwards, yeah, that might be interesting. Also, what I like to talk about is, I'm sorry, but life is not about technical problems. Technical problems are easy to solve. Like Agile. Yeah, Agile solved our way of doing things, right? Now that we are all doing Agile, everything is fun, everything. No, it changed nothing. Why? Because first step is trying to be Agile, to do Agile. Most organizations are on the first step. Some organizations are doing Agile by following the process. Where is the agility? I've never encountered someone really being Agile, like, yeah, let's create together something. So microservices, as I told you before, the tenant is about having team. So each team is dedicated to one service. And the ideal size of the team should be fed by 2 pizzas. So you will tell me that depends on size of pizza. Yeah, okay. Anyway, you got my point. Still limited size. And what? They should be autonomous and self-organizing. Those are the key points. They don't need anyone. Yeah, that's cool, right? You want to be part of this team. You don't need no one. And that's how it worked at Netflix, right? Basically before, like in your old company, you had product manager, and you are UX designer, and you had developers, QA, and stuff. And then let's create a team by picking one of them for every job, and they don't rely on anyone. Is it your dream to be autonomous? Because I can tell you, that's the nightmare of middle management. if you remove them, if you put people into teams that are autonomous, where do they fit? Where do middle management fits? That's the problem. That's a real deal breaker, because those are the guys that can push microservices. Like they pushed Agile into some. They can really push microservices or not. And if they push microservices really nicely, then won't be used anymore. There is no use for them. Right now, the only use they have is to report to the higher ups and to check your vacations. Come on. Okay, who has had manager who did better than that? Not many. And now who has manager who does better than that? Even less. And that's the problem. In IT, I'm sorry, but middle management is completely useless. But IT is a new job, so basically we replicated the old structure of organization. And right now, it's completely not adapted. Most of our managers have no clue about what we are doing. So they did metrics, management by metrics. If you are autonomous, if you release regularly, if you are responsible to deliver, if you communicate with your fellow components and say, yeah, I will deliver this at this date, and you do it, and you say, no, I have to push a little, okay, I will do it later. Where is their value? Where are they needed? That's the real problem of microservices in your organization today. It's basically, it does not fit, not from a technical point of view, because, well, we can handle nearly everything that was thrown at us, but we cannot not handle organization changes. I mean, we are just code writers. We have no power. Or we have the true power, but let's keep it secret. So, microservices are better suited at small companies, new companies, or companies that have a flat organization. Basically, they are the same, because flat organizations are brand new. So, now I told you all about the shitty stuff. There is a light side. There is a rainbow. Because even if you don't use microservices, probably you use web services. And probably you use RESTful web services. Who consume RESTful web services here? Okay, so more than half the room. So this is for you. This is super important. Because people who need microservices created all the tools that were required. So let's use them. Even if we are not microservices, we are web services consumer. And here are just a few that I want to enumerate because they are super, super important, especially the first. The first one is Hystrix. Who knows about Netflix? Yeah, half the room. So Netflix basically just delivers videos, streaming videos in the US and in France and in some other country. Here, is Netflix here? Yeah, and in Ukraine. Good. Who here is a Netflix subscriber? Ah, not so many. There is not so much content? Okay. I'm not a Netflix subscriber, so I don't know how the product is. What I know is those people are using microservices and using them a lot. And though, like any company doing their own stuff, they created frameworks and tools and methodology, blah, 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 to help them. So let's check. So Hystrix is the most important. If you remember something about this presentation is that one, manager are useless, but that you already knew, and that Hystrix is super useful. That probably I don't know if you know it. So Hystrix provides you many, many different patterns that are useful in the context of web services, like a secret breaker, the fallback, cache, collapse, dashboard, and other. First one, secret breaker. The problem is probably it happened to you. You call a service. It works, that's good. It doesn't work. What does happen? It waits, it waits, it waits, it waits, and at some point, there is a timeout. And it returns saying, hey, I'm sorry. The problem is, during this timeout, this wait period, other requests are getting queued. And the queue grows and grows and grows and grows and grows, and basically, there is no point for them, for the other, to wait. What you want, probably, is after the first 1, 2, third failure, to say, okay, it's not available, fail fast. Tell that to the customer, tell that to the client. It's not possible. You want to fail fast, otherwise it will eat up your performance. So like in anything, it's better to fail fast. And so here comes the circuit breaker. Basically, by default, it works. So it's like in electricity. I'm sorry, I'm not an electrical engineer, but basically the circuit is closed, it works. After some point, if it doesn't work, if there is a failure, the circuit opens. And then it fails fast because it will tell you, no, there is no need to make the call, the circuit is open. After some point, there will be a tentative, like Esprit will try again to see if the component is available. And if the component is available again, then it will try for a few more times, and if it works, then it will say, oh, it's up again. So it will close the circuit again. Otherwise, it will open it. And this is super useful. It means you don't need to do that yourself. Okay, that's good, but what do you do when it fails? What data do I return the client? Istrik provides it. You have a fallback. You can have for each call return data, whatever data you need, default data. Like for example, let's take the example of the e-commerce shop. You probably have a pricing microservice that gives you the prices of articles. So every time you will ask for the most up-to-date price. If it doesn't work, what is better? To tell to the customer, sorry, you cannot buy it, I have no price, or to return a not up-to-date price. This is e-commerce, right? So it's better to return anything than nothing. So in that case, you might want to enable a cache and to return the latest price, even if it's not really up to date. You might lose a few cents, you don't care. At least the customer is happy because he could buy. Something that might or might not be interesting to you, that really depends. If you have a short burst of small network calls, every time you have to open a socket, send the data, close the socket. That is not super interesting. You can go through Istrix to collapse the request into one single big data payload with only one network call. That depends on your use case. That really depends on your use case. But it's possible through Istrix. The latest Istrix feature that is really great is it provides you a dashboard. So, as I told you, if you do microservices, you have to monitor. You have to monitor everything. And monitoring the success and the fail rate of all your calls is super important. So this is one of the tools that you get for free by using Istrix. So you can see, or you cannot see. Do you see the little beaming light or not? Yeah, not so much. So I will point. So here you can have the number of calls by the size of circle, and the color of the circle tell you red is not good and green is good, like many other, right? You've got a percentage here, and you've got many different other metrics that let your ops team follow everything and do something that is required, or perhaps call support or whatever. What is good also in Istrix, if you have 3 kinds of APIs. If you are, as I told you, if you prefer synchronous calls, because, well, it's not a problem if you wait too much, but you prefer maintainability, that your code is readable, that it's simpler, there is a synchronous API call. If you like to be asynchronous, then there is an asynchronous API. And finally, if you are all reactive, because reactive rocks, there is a reactive style of API. So you've got all 3. And in all cases, you use Istrix, but however you want. When you do microservices, basically, you want to call a server or a set of servers. You have no ID. Previously, what we did is, on the server side, we had some kind of load balancer. The problem with that is, well, it's on the server side, so it can fail. Yeah, it's by definition. So Ribbon is a client-side load balancer, and you can put any rules you want. It has a pluggable architecture. You can write your own stuff. So for example, the rules are super simple. You can have some round robin, like normal simple stuff, or you can filter by availability, like, yeah, if the latest call were not working, then I will remove it from my list. Or you can check the response time, or you can create your own rule to do load balancing. So it's really whatever you want. And you can provide the server list directly in the code or in the configuration, or have a Eureka server behind. As for Eureka, it's a registry for middle-tier load balancing. So you would have server registering, saying, hey, I'm available. So when you create a new server, it can register to the Eureka server, and client can download the configuration from here every time. So you can put more servers when it's required, or remove servers when they are not required. Also, you have Feign, which is a REST client based on annotations. So if you don't want to always write the same code and stuff, you can just annotate it for some common use case, and it makes creating clients super easy. More importantly, if you already are using Spring, you already have all of this for free through Spring Cloud. Who here is a Spring user? Half the room. Who here is a Spring Cloud user? Okay, 10 people, less than 10. So you already have this for free. It's just a dependency. And to be honest, I've looked at the origin. I'm a Spring user myself. I've looked at the Netflix APIs themselves. They are not so easy. They are not so easy to call themselves. So if you can use Spring, it's super, super, super nice. So as a summary, you are an engineer. I don't know if there is feminine form of engineer, but or an engineerette, I don't know. You should adopt an engineer mindset. What are the costs? What are the benefits? Is it feasible? And when I say feasible, it's also part of your responsibility if you are a team leader, if you are an architect, if you have any kind of power, of decision power, to evaluate the feasibility of, is it feasible technically, but also in my organization. And that's why I did this talk, is because I think that many people only look at the technical part of things, because we are engineers, right? If you are there, it's because you don't like people. You like computers. It's easier to deal with code than to manage people. I know, I do the same kind of stuff. Unfortunately, we are living in a world full of people, whether you like it or not. So you also have to understand how your organization works. Again, if you have a lot of middle managers that are useless, most of the time, sorry, if you have a lot of this kind of people that don't provide so much value into your organization, the problem is they will probably won't push microservices. They will probably halt microservices wherever they can because they won't fit into the new organization. That's a real deal breaker. You have to really check that. Now, if you have managers that are useful, they will probably push it and find places for themselves, or perhaps afterwards they will go to another company. This is the stuff that you have to evaluate before even thinking about microservices from a technical point of view. Now, I've done some trolling. Now would be some time for Q&A, so you can not follow my blog, follow me on Twitter, and be my friend on LinkedIn. So who has any comments or any suggestion or question or whatever about microservices and manager? Not about managers. Enough is enough.
What tools do you use in continuous delivery? What tools do you use in continuous delivery?
It depends. The problem is I am a consultant. So basically, we did continuous delivery. We didn't do continuous deployment. The last time, on my previous customer, we used Puppet. But, yeah. But Philip, where is Philip? Philip, here we push for Ansible. He has talks on Ansible. You can talk to him about Ansible. Sorry? It's much nicer than Puppet. You want to push containers directly. That, to be super honest, I've never done it. So I cannot give you any insights into that.
I'm afraid you will need more managers than before within microservices because, for example, you'll need to organize all microservices to be deployed in such a way that one microservice will not break another microservice. You will always have not a stuff like the same team working on having control of the whole code, but only on its own microservice, so it need to go to another team asking that, could you please add this to your API? And they will reply, yes, of course, according to our timetable within next year, etc., etc.
Yes and no. It might be an option. So the question was, yeah, you will need more manager instead of less. If we are talking about purely technical stuff, and people willing to go to talk to other people, not like my caricature, I mean, why would I need a manager to go to the other team and ask them, hey, could you please change your API? Because it will take me more time. Basically, I will have to explain to the manager what it means, because probably he has no clue. Then probably I will already need to come with him to a meeting with the other manager's team and the other technical leader of the other team. And it will end up that we will basically talk between technical leaders. You seem to disagree. It's okay. And sorry? It's all about budgets. That's another problem that we might talk another time, is this stuff of scope and budget is, in my opinion, a thing of another time. Because if, I will tell you one simple example. Let's say that I want a connected washing machine. I am a big company, I'm Samsung, and I want a connecting washing machine. Yeah, it's completely useless, but it's hype. So basically, I will have one part of my company, basically the people who buy, they will have their objectives, and the people who develop afterwards will have their own objective. The people who buy, probably his objective would be to buy the cheapest chip. Whatever, the cheapest. because then he will shave off a lot of money, then he will meet his objective, and he will have higher revenue. But then what happens? If you have the cheapest chip, not Wi-Fi, Bluetooth, then it will cost a lot more in the development team. And that's what I have seen. So the question of budget is super important, and you are right. It's all about budget. But thinking that adding local optimum will produce a global optimum, I don't even cannot comprehend how managers who are paid a lot cannot understand that it's complete bullshit. Because even I can do that. The sum of all local optimum trying to optimize every part of your service, every department, every team doesn't sum up. It's false, it's wrong. Come to me later and let's talk about it, because it's super interesting. I don't know how we can change things, but we should, because it's really stupid. And about the washing machine, I worked in such a context. And of course, it was not about washing machine, but I experienced it. So it's not plain hair. Other questions? Yeah.
Thank you for the speech. There are lots of discussion regarding the approaches which we can to choose with new development from scratch. So the question is, from your opinion, when we start a new project, what options, what we need to consider to choose development in a monolith way or in a microservices way? Your opinion.
My opinion is it's contextual.
Of course.
So it's super easy. It's a basic consultant. If you have no clue, if you don't know, but you have experience in building monolith, that you have experience in of. So do it the way you know, because if you start something, you want it to succeed. Because if it fails because you chose microservices, it's wrong. When it's successful, then you can start considering migrating. Because when you start a new project, basically you won't have many customers, so scaling is not a problem. That's what you would advise without knowing any context.
I got it. But next question. In case we started from monolith, or for example, we have a legacy application.
Yeah.
And we need to move to microservices.
Do you need or do you?
For different reasons.
For different reasons,
For example, your suggestion, how can we split already existed application, already developed application, for example?
That also depends on your existing architecture, but what I would do is probably I will start in the API, starting to decouple the package. Like one package is completely independent, right? And that having its own data source. And then only then I could deploy, I'm super pragmatic. I'm a step-by-step kind of guy because I've seen too many big bang fail. So every time, it will take more time, but you have less risk. In that case, I would advise that the risk is the biggest problem. So side by side, really step by step, start inside your monolith, like they are doing in GDK, for example, about Jigsaw. They are starting to decouple package by package. And then only when they have decoupled the package, they saw no dependency. Then they can decouple the stuff and put it into its own component.
Okay, got it. Thanks.
I have a question regarding future. So you described problems or issues with microservices. They're probably truthful and they are there. And you provided some insight on tools which solve some of the issues, correct? In your opinion, what other tools can make microservices development easier? What tools should we follow? Maybe they're interesting and have some perspective. And what are missing?
From an organizational and technical point of view, I think that you should read the Netflix blog, Netflix stuff. They really seem to be in the know. They really did it. It works. So probably they are subject matter experts. And even the way that they create teams, but then create, like, if you put one developer, one UX, one QA, one into the same team, the problem that you lose coherency over all developers that cannot share their experience and stuff. So they created guilds to unite them. They seem to be really, also from an organizational point of view, they are really advanced on the subject. So if you want to decrease the chances of mistake, then I would advise, to follow them, what they write and what they talk about.
Thank you.
Other questions? Okay, thank you very much, and enjoy.